Before the invention of the Hindu-Arabic number system, the most advanced number system was the Babylonian number system. The place values were ones, tens, and sixties. The ones used a standard cuneiform stylus, the tens were drawn with a special stylus, a triangle with two extended lines, and the sixties were also drawn with a standard cuneiform stylus. You were able to distinguish between the ones and the sixties because the end of the triangle that did not have the lines extended from it was pointed towards the sixties. There were two main problems with this system. The first was it was impossible when there were no tens to see if you meant for the symbols to mean ones, sixties, or both. The other problem was it was hard to read and write large numbers. Can you tell what this says? A man named Aryabhatta invented another system. Aryabhatta was born in a state of modern India called Bihar in 476 CE. He used the letters of the Hindi alphabet as symbols for his new system. He understood the importance of place values and zero, something not understood before him, and used his knowledge when developing it. This system is a system we use today, using the values 0 through 9. The people after his time used this system to do accounts and settle other matters. It was their way of counting. In the Islamic Crusades, the Muslims came across a far better and more advanced number system than anything they had ever encountered. It was the system Aryabhatta invented. The Muslims had access to the systems of the Romans, the Greeks, the Babylonians, and lots of others. They saw the value of Aryabhatta's system and brought it home to their mathematicians. With this system, you could easily express large and small numbers without confusion. You could express parts of numbers, infinite numbers, and negative numbers. Although the Indians invented this system, they did not see the value of it. To them, it was just another system invented by just another civilization. With this new and advanced system, the Muslims made many discoveries in math, science, and art. Since both civilizations made major contributions to the system, the Indians invented it, and the Muslims raised awareness about it. We now call it the Hindu-Arabic system of numeration. One of the most influential people in the Muslim world of math and science was a Persian astronomer and mathematician named Muhammad ibn Musa al-Khwarizmi. He was born in what is now western Uzbekistan and lived from about 780 to 870 CE. His Latin name was Algorithmi, and from it we get the words arithmetic and algorithm. An algorithm is a process which you follow to reach the answer to an equation. He did a lot of research in the House of Wisdom, a library in Baghdad, and wrote a book that popularized Aryabhatta's system, preserved Greek works, and brought forth new ideas. This book was called Hisab al-Jabr wal Muqabla, the book of calculations, restoration, and reduction. Take a moment to consider the second word in this title, al-Jabr. In Arabic, this world-shattering word means returning to original. Does it remind you of anything? From its root, we get the word algebra, the concept of finding unknown numbers. In the book are rules of algebraic equations, square roots, squares, and fractions. It also applies algebra to real-world problems like inheritance. Did you know that the reason why we use the letter x as a standard variable is because in his book, Al-Khwarizmi called the variable shay, meaning thing, in Arabic. However, when translating it to Spanish, it was written xay because in ancient Spanish, x made a sh sound. Eventually, it was shortened to just x. He put linear and quadratic equations in 6 forms. 1. Roots equal numbers. 2. Roots equal squares. 3. Roots and numbers equal squares. 4. Squares equal numbers. 5. Squares equal roots and numbers. And 6. Squares and roots equal numbers. Al-Khwarizmi solved quadratic equations using squares and rectangles. Let's say we wanted to solve the equation x squared plus 10x equals 39. First, he drew a square with the side of x, making its area be x squared. Then he added 4 rectangles, their areas adding up to 10x. Each rectangle had an area of 10/4 x. This must equal 39. Then, to make the figure a square, he filled the remaining area with 4 squares, 10 fourths by 10 fourths. Each square then had an area of 25 fourths. Since there were 4 squares, they added up to an area of 25. 39 plus 25 equals 64, so the big square had an area of 64. The square root of 64 is 8, so each of the sides of the big square is 8. Then, to get x, you have to subtract the part of the side that is 10 fourths on both sides. 8 minus 10 fourths equals 5 1/2. 5 1/2 minus another 10 fourths is 3. So x equals 3. Today, using another faster method called factorizing, we know that x can also be negative 13. There were other Muslims who made significant contributions in the mathematical world, but I don't understand, therefore cannot explain what they discovered. Without the Islamic civilization, we probably would not be where we are today in the world of math and science.